Hi, dear students. Good afternoon. I am Dr. Biswajit Gayan, Assistant Professor from the Department of Chemistry, Dr. Sudhit Chandrasud Degree Engineering College, Dom, Kolkata. Student, today we will discuss about the two very important principle or statement in quantum mechanics, or basically these two statement is the base of the quantum mechanics, or you may can say, as we are dealing with the chemistry, so we can say the quantum chemistry. So what are they? The number one is de Broglie hypothesis, and number two is Heisenberg uncertainty principle. Clear? So today I want to discuss mainly two things: de Broglie hypothesis and Heisenberg uncertainty principle. Now you have already idea about the quantum mechanics and the classical physics. Now the classical physics and the quantum mechanics are somewhat different. In case of the quantum mechanics is mainly applicable for microscopic particle like electron, proton, neutron, etc. But the classical physics is applicable for the or Newtonian mechanics or Newtonian physics applicable for the macro matter like any particle, football, cricket ball, etc. For if we just consider the cricket ball, so when one throw the cricket ball, it follow the Newtonian mechanics or classical physics or classical thing, because when a cricket ball move, we cannot find its wave nature very simply, but we have no such idea about the electron. So when electron rotate around the nucleus, whether it move directly or it move with its wave function or wave nature, we have no idea. Still 1924, because de Broglie developed or offered this his hypothesis on in 1924. Now come to the direct point or direct thing, that is what is the thing said by de Broglie. De Broglie is a scientist who tried to correlate the particle nature and the wave nature of a particle, because when uh, a microscopic particle like electron moves, only the particle nature cannot explain all the phenomenon caused by the electron. So some cases the wave nature is required. So keeping this concept, de Broglie try to correlate it. So very nicely and very easily, better I can say, very easily he did his job. He derived this concept or correlate the wave nature of a particle and particle nature of a particle, that is again I am saying this is applicable for the microscopic particle. So so here he did this by, we know that according to the Planck, the energy of a photon, the energy of an photon E equal to h nu. And again the great scientist Einstein mass energy relation, the energy is given by E equal to mc square. Now if we correlate the equation 1 and 2, we got mc square equal to h nu, where m is the mass of the particle, c is the velocity, and you know that the c is the speed of the light, h is the Planck constant, nu is the frequency. Now nu can be replaced by c by lambda, where c is the velocity and lambda is the wavelength of the particle. So by correlate this thing, we can write lambda or the wavelength equal to h by mc, or we can write h by p, because p is the momentum. So here the final equation is, or the mathematical form is lambda equal to h by p, or the momentum. Now the question, what is the statement? According to him, or de Broglie hypothesis, every object which possesses some mass and has some velocity behave both as a particle and as a wave. So in our language we can say, student, that for microscopic particle like electron, proton, neutron have both particle as well as the wave nature. Clear? And it is correlated by lambda equal to h by p, where lambda is the wave nature and p is the particle nature, because momentum is related to the particle nature, but lambda is related to the wave nature. Is this clear? And there will be lots of yes, student, here this lambda is basically the de Broglie wavelength for this case. You were saying that there is some problem. I will discuss later with this problem, and I hand over this problem to you. But before that, I want to discuss about the Heisenberg uncertainty principle. Now again, one of the great scientists, that is Heisenberg, offered some observation or some principle, or not some but particular principle, which help the quantum mechanics to keep or to stay on his own feet by the quantum chemistry. That is, these are, again I am saying, the Heisenberg uncertainty principle, de Broglie hypothesis, all are the pillar of the quantum mechanics. So this is the initiation or the initial starting of the quantum mechanics. Now Heisenberg uncertainty principle is very simple. For again I am saying, these all are applicable for the microscopic particle. So microscopic particle like proton, electron and neutron, the position and the momentum, please be careful, position and the momentum of an object like electron cannot be measured exactly. So for electron, you cannot detect or measure the position exactly. If you want to measure the position exactly, then the momentum will be infinite, or inversely, if you want to measure the momentum exactly, then the position of the electron will be infinite. So mathematically it can express by del x del px greater than equal to h cross by 2. Here del x is the uncertainty of the position, and del px, there is the uncertainty of the momentum along the x-axis, and h cross is nothing, h cross is equal to h by 2 pi, where h is the Planck constant. So the same thing we can say, that is del x del px greater than equal to h by 4 pi. So this is very important thing, student, please remember it. That is the de Broglie hypothesis and Heisenberg uncertainty principle are very important for your syllabus. So these two things will explain or solve different problem and different situation in quantum chemistry. And here these are the mathematical problem. So obviously I will discuss with this mathematical problem with this class in the next class. So that's all, student. Today I finish here, and in the next class I will want to discuss about the some mathematical problem and the main thing of the quantum physics or the quantum chemistry, that is Schrödinger equation. So I hope you enjoy the class, and student, if you face any kind of problem, please reach to me, and I am eagerly waiting for you to solve your problem. Thank you. Take care.